So if we want to solve a problem using Ohm's law, what potential difference must be applied across a 2,755 ohm resistance in order that the resulting current be 98 milliamps? Okay, so recall first that milliamps is 0.098 amps. Right? We're just going to divide by 1,000. Let me write that a little differently. Milliamps, like millimeters, is just a thousandth of an amp. So there are 1,000 milliamps in 1 amp. So you just divide by 1,000, and that's where I got the 0.098 from. Our resistance are 2,755 ohms. And so to find the potential difference is the voltage. And so that's going to be I times R, 0.098 amps times 2,755 ohms. And when you multiply the two, you'll get 269.99 volts, or we could just call that 270 volts. Finally, in the last problem, or in the last part of the section, we talked about electric power. Like mechanical power, electric power measures the work done by the circuit, right, to move the electrons, or to use an appliance, for example, which would come about for moving the electrons. We can calculate the power consumed in an electric circuit by just multiplying the voltage times the current. And if we use Ohm's law there and just replace the voltage with what we know the voltage to be equal to, then you can also see that you can write the power as the current squared times the resistance. Recall that power is measured in watts. And so let's take a look at the last problem here. If we have a 75-watt light bulb connected to a 120-volt power line, how much current is flowing through it? And then on the next slide, we'll figure out what's the resistance. And so our power is 75 watts. The voltage is 120 volts. This is very similar to what you might see in your home if you were using an older light bulb. Most light bulbs don't use 75 watts of power anymore. And so if we wanted to find the current, well, the power is just equal to the voltage times the current. So the current is equal to the power divided by the voltage, or 75 watts divided by 120 volts. 75 divided by 120 is going to be 0.625 amps. And now if we want to know the resistance, there's a couple of ways we can solve this, but I would just solve this using Ohm's law. Much like we know from Ohm's law, the voltage is equal to the current times the resistance. We can also determine the resistance as the voltage divided by the current, which in this case would be 120 volts divided by 0.625 amps. And when you divide those two, you will get a resistance of 192 ohms. And so we have the resistance in the circuit and the current. And I think I was meant to do this second part on the next slide, but I'll show you one last thing. If we wanted to find the resistance without using the voltage, but instead using that second equation, we know that the power was 75 watts, the current 0.625 squared times R, And 0.625 squared, let's see, 0.625 squared would be 0.390625. That's R. I'm not sure where that line came from. We'll just then divide by 0.390625. And you should still get the resistance to be equal to 192. And you do. I was just making sure I didn't make any mistakes. What's happening with those extra lines there? So it doesn't matter which of the formulas or which way you do it, you can solve it either way. So this brings us to the end of the week 9 and the week 10 practice problems. You'll have an extra week to do the week 9 stuff along with this stuff from week 10. We'll do a little bit more next week. If you have any questions or if there's any way I can help you, please let me know. And I will be back soon with another video. You guys have a great week.